Hello all. In this video, let's solve this problem of finding the middle element of a given singly linked list. And the problem number is 876, that is 876 in the lead code portal. And let us get into the description. We are given the head of a singly linked list and we have to return the middle node of the linked list. If there are two middle nodes, we have to return the second middle node. See the example. The singly linked list contains the elements 1, 3, 4, 1, 2, 3, 4, 5, and the middle element is 3. So we have to return this middle node 3. In case of singly linked list with even number of nodes as of example 2, we have to return the second middle element, that is 4. Okay, and now let us implement this. Before entering into the implementation part, we have to know some basic concepts like in this code we are given with a definition for singly linked list. Here the class list node will store the values of the nodes as well as the pointers like the next node, the previous node. So these informations will be present in the class list node. So that is what we are using in this method middle node also. Okay. So here we are going to use a two pointer approach. What this two pointer approach will do is, initially we'll be having two pointers and the first pointer will point to the head node. The head node is nothing but the first node of the given singly linked list. The same way the second pointer will also point to the first node, that is 1 in this case. So initially both the pointers will point to this head node, and the first pointer will point to the immediate next node, and the same will be continued until it reaches the middle element, whereas the second pointer will point only after two nodes. Initially it will point to node 1, and at the very next iteration it will point to node 3. In the next iteration it will point to the node 5. So let us have two pointers. Let the first pointer be slow, which iterates through each and every node. The second pointer, let we consider the name as fast, since it is iterating, it's jumping over the nodes, right? So let us take it as fast node. Fast pointer. So now both the slow and fast pointers will be in the head. That is nothing but the node one, and will performing this. So here what is the logic is, when the fast pointer points to the last node present in the singly linked list, which means the node's next is null. So in such case, the single, which means the slow pointer will be pointing to the middle node of the singly linked list. This is what the concept is. Okay. So now let's go to the implementation part. Let me have two pointers. The first pointer is list node slow, and that is pointing to the head node. The same way we have list node fast, that is also pointing to the head node. Okay, what is our condition? Our condition is this fast node should not be null. The fast node should not be empty, and at the same time fast's next should also not be null. So it should not be null, right? When this fast reaches 5, this 5's next, that is the fast's next is null. So in such case, this while loop fails. Okay, when it is not null, we are going to harvest this slow from this 1 to 2. So slow will become slow dot next, and fast should jump to 3 from 1. So to jump from 1 to 3, fast is equal to fast dot next. So only then it will point to 3. So fast is equal to fast dot next. Simple. Once we complete this, see, in the very first thing, we're entering into this example and we see 1 as the head node. So both slow and fast are assigned to 1, and we're coming to this while loop. Fast is not equal to null. Yes, fast is not equal to null. Fast is here only. Fast's next is also not equal to null. Yes. Then we're moving slow to slow dot next. So this is the current slow. And fast is fast's next of next. So fast will become 3. Now slow is 2, fast is 3. Again, we are going to the while loop. Fast is not equal to null. Fast dot null is not equal. Fast dot next is also not equal to null. Now again, slow will become 3 and fast will become 5. Since fast is in the last node, again we'll be checking the condition. Here the while condition fails. The while loop fails because fast's next is null. So I'm simply going to return slow, because when fast reaches the very end of the singly linked list, we could see that the slow is pointing to the middle element of the node. The middle node is pointed by this slow pointer. Hence, this is how we find the middle element in a singly linked list. In case of even number of nodes present in the singly linked list, it points to the second middle node present in the singly linked list. Now let us compile this. Yeah, both the test cases are passed, and now let us submit this code. We can see that our solution is accepted and we have solved this problem. Okay, so this is how we implement and we find the middle element of, or the middle node that is present in a singly linked list, and this is the implementation in Java. Thank you.